Hello students, today we are going to talk about Millikan's oil drop experiment. The Millikan oil drop experiment, conducted by Robert A. Millikan in 1909, is a landmark experiment in the field of physics. It was designed to measure the charge of an electron. The primary goal of Millikan's oil drop experiment was to determine the charge of an electron with high precision. Let's check the setup for the experiment. The setup consisted of: atomizer is used to spray fine oil droplets into a chamber. Chamber is used to contain an upper and lower section, with the lower section containing two horizontal metal plates. Microscope is used to observe the oil droplets. The X-ray source was used to ionize the air in the chamber. Electrical supply is used to create an electric field between the metal plates. Let's see the procedure. The atomizer sprayed tiny oil droplets into the upper chamber. These droplets would slowly fall under gravity through a small hole into the lower chamber where observations were made. Millikan observed the falling oil droplets through a microscope. By adjusting the focus, he could pick a single droplet to study. When the experiment was started, the electric field between the plates was turned off. The oil droplet was allowed to fall freely under the influence of gravity. Millikan measured the terminal velocity of the falling droplet, which is reached when the gravitational force is balanced by the air resistance. Now, Millikan will apply electric field. An electric field was applied by charging the plates. The field could be adjusted to make the oil droplet move upward, downward, or remain stationary. By adjusting the strength of the electric field, Millikan could suspend a droplet in mid-air, achieving a condition where the upward electric force balanced the downward gravitational force. With the droplet stationary, the forces acting on it are balanced, means the gravitational force equals the electric force. Millikan used the terminal velocity when the droplet was falling without the electric field to determine the mass of the droplet, using Stokes' law to relate the velocity to the radius of the droplet. Knowing the electric field strength and the mass, he calculated the charge on the oil droplet. Now, let's check the conclusion of the experiment. By repeating the experiment with many oil droplets, Millikan observed that the charges he calculated were always multiples of a smallest value, which he identified as the fundamental charge EE. He determined the charge of an electron to be approximately 1.602 times 10 raised to the power 19 coulombs. Let's see the significance of this experiment. Millikan's experiment provided the first precise measurement of the charge of an electron, confirming the quantized nature of electric charge. It supported the atomic theory of matter and the existence of subatomic particles. That's it for today's video. Until next time, stay safe and keep experimenting.